we obviously have our point. How can we use this information to find our slope? Nate, what do you think? Okay, so let's just say add my y over, and I'll add my 1 over. So it'll look like that. Go on. Right, so this line has a slope of 2. So being that parallel lines have the same slope, we're also going to use a slope of 2. I'm just going to write parallel slope equals 2. So with that point slope, we just write our equation. Y minus 1 equals 2, x plus 3. Done. And perpendicular, we obviously have our point, and they don't tell us what slope to use, but they tell us that they want our line to be perpendicular to that one. So, Morgan, what can you tell me about the slope? The slope that we should use to write our line, the perpendicular slope. Yep. Perfect. Yep, the opposite reciprocal. Very good. So that's just going to be y plus 5 equals 4, x minus 3. Done. Average rate of change at the bottom here from x1 to x2. Obviously, it's the change in your y coordinates over the change in your x coordinates. Now that we're in algebra, well, beyond algebra 2, we don't really call it a y coordinate anymore. We call this point x1, comma, f of x1. And this point is x2, comma, f of x2. And then we just do our slope formula that way. So f of x2 minus f of x1 over x2 minus x1. Okay, so we'll flip to the back and take a minute on your own, calculate your 3 different average rates of change on that function f of x equals x squared. First from 0 to 1, then from 1 to 2, and then from negative 2 to 0. Is anybody stuck? Because I'm sort of just assuming you know how to do this. If you're going to find the average rate of change, you need points, yes? We don't have 2 points yet. What we have are 2x coordinates. So we have a point 0 comma something and a point 1 comma something. You're going to find out your y coordinate that pairs with 0 by plugging 0 in. You're going to find out your y coordinate that pairs with 1 by plugging 1 in, and then you'll have your 2 points. Mitch, what'd you get for part A? Slope of 1, I believe is correct because we have 0, 0 and 1, 1. Good. B. Bailey? Did anybody get anything different? I didn't do that one yet. So we got 1, 1 and 2, 4. Perfect. Looks good. And then part C. Bridget. 2. Did anyone get anything different? Good. So I'm negative 2, 4 and 0, 0. Good. So it's simple. Yeah.
It would be negative 2.
It would be. How come no one told me they got anything different? You can't be silent, Bailey. Good for you. Thank you. You know what? Just for that, I'm going to reward you with a bonus plate. What the heck? Speak up. Otherwise, I'm going to assume y'all got the same thing, and why would I do the math all over again? Yeah, Andrew, we got another problem?
Does it have anything to do with adding those together? Like negative 2 and 0 and 1 and 2 and 4.
Wait, say that again?
Because the slope is negative 2 and it's negative 2 to 0. And then negative 2 and then 1 and 2 and equals 3. Does it have anything to do with adding them together or no?
Well, we'll find out. I don't think so, is my short answer. I think that's just a coincidence. But if you ever had like a, do you see what he's saying? This one has a slope of 1. Well, coincidentally, if you add 0 and 1, you get 1. From 1 to 2, it's a slope of 3, and coincidentally, if you add those together, from negative 2 to 0, if you add those together, you get negative 2. I think that's a coincidence. But if you ever notice a pattern like that, again, 2 of those coincidences happening is, possible. 3 of them happening is like, well, it's a little more convincing. I still think it's a coincidence, but let's just check something random. Let's go like 2 to 6, which by his logic or suspicion would have a slope of what, Andrew? 8. So let's see if that happens. 2, 4, and 6, 36. 36 minus 4 is 32 over 4 is 8. Huh. I'm still suspicious. This is going to be fascinating for me. What if I do like a negative to a positive, like a negative 4 to positive 3? If this one works, I'm sold. This one works, I'm sold. So negative, this by your logic should be negative 1. Oh God, I think it might be. It's definitely negative. Negative 4, 16. 3, 9. 16 minus 9 is 7 over negative 4 minus 3, negative 7, negative 1. Andrew Genzo. That is, now for the record, it's definitely a coincidence for this type of function, but I would have to say when 5 of them work, it's like almost certainly true. But still in math, we have to prove things. And just showing, even if you showed 100 examples of where this works, it's 99% convincing, but it's not a proof until you do it generically. So if we were to come up with sort of a generic version of this, let's pretend we want to find the slope from point A to point B. Yes? So by Andrew's logic, this should, Andrew, have a slope of what? A plus B. That's the conjecture here. That is what we are seeing if this little shortcut works. So for this function, if you plug in A, what's the y coordinate going to be? A squared. And if you plug in B, what's the y coordinate going to be? B squared. So if you're going to do the slope formula, it's going to be B b squared minus a squared over b minus a. And now I think we can probably see why this is happening. Because the numerator is the difference of perfect squares. Yes? Which can be factored into b minus a, b plus a, one of which is always going to cancel with the denominator and will always leave you with a slope of b plus a. Well, well, well. That was not what I intended to go over with you today. Andrew, I got to give it to him. That's a 2-pointer. That's pretty interesting. Good $1 million proof. Wow, love that. Anything, keep it new and fresh for me. My gosh, pretty cool. All right. Average velocity. Velocity is, you all know, change in distance over the change in time, right? In math, we really call that position. It's your distance, so change in position over change in time. For whatever reason, I don't know, I'd have to Google it. Position is notated with an S. Time is a T, so that's fine. So, oh boy. The short of what we were about to do here, until Andrew had to go and find something interesting for me. Right? Are we almost done?
Yeah.
Okay. What we would do is we would find the position at 3 seconds, and we would find the position at 4 seconds, which I'll do really quickly. 345 and 16 times 5. 80. 480. And I would get a velocity that is 35 over 1. So 35 feet per, what's our unit for time? Seconds. And then we're going to pinch in. So 3 to 3.5 is going to have a different slope. And then we're going to pinch in even closer to 3. And this is very similar to our H's pinching in the other day, right? Slope between 2 points, that's a secant line. This is still a secant line, but the points are pinched closer together. This is still a secant line, but the points are pinching closer together. So what we're getting closer and closer to is the instantaneous velocity at what second, Mark? 3, because we're pinching in towards 3. We're letting our second point get infinitely close to 3. So this number is going to get closer and closer to the instantaneous slope at the 3 second mark. I shouldn't say slope, I should say velocity. Trista? No. Feet per second squared would be acceleration? Yeah. So your y2 minus y1 is position minus position, so that's some number of feet minus some number of feet, which is just feet. And 4 seconds minus 3 seconds is just 1 second. Okie doke? Good convo.